Every year, the United States gets more tornadoes than anywhere else on Earth. Some are brief and almost impossible to see from a distance, touching down over open fields for only a few moments before fading away. Others something far more violent, tearing through towns, lifting cars, ripping apart homes, and leaving behind scars that can be seen from the air. Tornadoes may seem random in nature, or like they have no order, but we can see patterns with tornadoes, and we see in the Great Plains, also known as Tornado Alley, that they are regularly being hit by these things, whether they be small or large. And recent years we have Dixie Alley, where more and more tornadoes are appearing, and again appearing at night with more violent structures. And all of this really comes down to three different separate factors: geography, climate, and air masses moving over the top of the continent. And if all of those mix together and overturn in just the right ways, the consequences can be catastrophic. To understand why America gets so many tornadoes, we must first understand what a tornado producing situation looks like, because it's a lot more than just randomly spinning winds. Most tornadoes are formed by powerful thunderstorms, specifically a type of thunderstorm called a supercell. And a supercell is a thunderstorm with a giant rotating updraft. They're organized, they're long-lived, and quite frankly can produce some of the most severe weather on the planet. But before a storm can get to that point, the atmosphere has to have just the right ingredients within it. And there are four major ones. With that would be moisture, instability, lift, and wind shear. First, let's look at moisture. This usually means warm, humid air near the ground. Moisture acts as a fuel for thunderstorms, and when warm, damp air rises, it cools and the water vapor inside it condenses into cloud droplets. And that process is releasing heat, and that heat helps the rising air continue to rise. So moisture does more than simply create clouds and rain. It helps power the storm from within itself, and the more warm, humid air a storm can draw into it, the more energy it has available to it. Next up, instability. And instability describes how willing the atmosphere is to let air rise. If warm air near the surface is lifted and stays warmer than the surrounding air, then it will keep rising. And as it rises, a storm can grow taller, stronger, and more intense. The classic setup for this would be warm, moist sort of air near the surface with a colder air above it. The warm air wants to rise, and the cold air above helps create this strong temperature contrast. And the greater that contrast, the more energetic the atmosphere can become. Our third ingredient is lift. And lift is a little bit like a trigger. Even if the air is warm, humid, and unstable, it often still needs a little push to start rising. And that push might come from a cold front, where colder air forces warmer air upwards. It could come from a dry line, where dry air meets the moist air. It might even come from a boundary that's been left behind by an earlier storm, or terrain forcing air uphill. But without lift, the ingredients can just sit there simmering, unused. But when lift arrives, the warm air is forced upwards, the clouds begin to grow, and, storms can develop quickly. And that would be the three ingredients you'd need for a thunderstorm. But the next ingredient is what you need for a supercell, which would bring us to wind shear. Wind shear means the wind changes as you move up through the atmosphere. And there are two main types of wind shear. There is speed shear, and there is directional shear. Speed shear is when the winds get faster with height. For example, the winds near the ground might be moving at 15 knots, while higher up it's moving at 50 knots. Directional shear is when the wind changes direction with height. So the winds near the ground might be moving from the east, while winds higher up are moving to the south or maybe to the west. In real severe storm setups, you often get both. Winds that become stronger with height and also turn as you move upward through the atmosphere, and that matters because these differences can help create a kind of rolling motion in the air, almost like an invisible tube spinning horizontally. And when thunderstorms updraft rises through that environment, it can tilt that horizontal rotation upwards. And if the storm becomes organized enough, the updraft itself can begin to rotate. And that rotating updraft has a name. It's called a mesocyclone, and it is one of the defining features of a supercell. Wind shear alone does not guarantee a tornado, and most thunderstorms never produce one, and even many supercells do not produce tornadoes. What wind shear does do, though, is give a storm the chance to become more organized, longer lived, and rotating, which is why it is such an important ingredient in the storms most associated with stronger tornadoes. So we have wind shear helping the storm to rotate and stay organized. We have instability, which is giving the storm the energy that it needs to continue. We have moisture, giving it the fuel it needs and powering that storm from below with its updrafts. And then we also have that lift to give the storm the initial oomph that it might need to get started. And all of that comes together to create these severe thunderstorms or these severe weather events that we see across America, across the United States. And some of these become supercells, and of course these then can often go on, or sometimes go on, to produce tornadoes. But this is where America has its problem, because it has all four of these ingredients, and it has them often and over a huge area. But then the question becomes, why? Why does America have all of this so much? So to answer that, let's start with the first piece of the puzzle, the Gulf of Mexico. For severe thunderstorms, moisture is fuel, as we've just been over, and the Gulf of Mexico is a great source of that. A large body of warm water sitting directly below the central and eastern United States, and as air moves across the Gulf, it picks up heat and it picks up water vapor, and that warm, humid air is carried northwards into places like Texas, Oklahoma, Arkansas, Mississippi, and beyond. And this matters because tornado-producing storms do not form in dry, lifeless air. So, while the Gulf is not creating tornadoes by itself, it's definitely giving it a fuel source. It's supplying it one of the most important ingredients, a steady source of warm, humid air. And because of the geography, there are no major mountain ranges blocking that air from moving north. Gulf moisture can spread deep into the central United States, and that is one key difference between America and many other parts of the world. So, if we're asking why America gets so many tornadoes, the Gulf is definitely a key part of that puzzle, providing all the fuel it could ever need. However, we know it's not the full piece, so to get the view of the next piece, we'd have to take a look at the winds that are colder and drier coming in from the north and the west. Moisture gives storms fuel, but for the atmosphere to become truly unstable, that warm air needs something to clash with. And in North America, it often gets exactly that. From north, colder air can push down from Canada. The air is denser, cooler, and much less humid than the air coming up from the Gulf. But at the same time, dry air can move in from the west, spilling off the Rockies and the high plains, and that drier air helps create really sharp boundaries in the atmosphere, especially when it meets the warm, moist air moving in from the north, from the Gulf. So over the central United States, you can end up with three very different air masses trying to occupy the same broad region. Warm, humid air from the south, the cold air from the north, and the dry air from the west. And when those air masses meet, the atmosphere becomes much more volatile. Warm air is lighter, so it wants to rise. The cold air is denser, so it wants to sink and push underneath. And the dry air and moist air create another sharp contrast. And these boundaries act like trigger zones where air can be forced upwards. And when warm, humid air is forced upward into colder air above, thunderstorms can grow rapidly. And this is one of the reasons the central United States is so storm prone. It is not just the country has warm air or cold or dry air. It's that those air masses can meet over huge open areas, and that collision creates the kind of environment where storms do not just form, they thrive, they explode. And if wind shear is also present, those storms might not just become strong, and become organised, rotating, and that's when the tornado risk really starts to become much more serious. The central United States is dominated by the Great Plains, a huge open region stretching across the middle of the country, and compared with many other parts of the world, this landscape is broad, exposed, and relatively flat. And that matters because there's no major east mountain range blocking the warm Gulf air from travelling north. The Great Plains leave the middle of the country exposed, and all those air masses moving around in the different directions can collide over this area. And it's why the United States central area is so important to this tornado story. It's not just the ingredients existing, it's this battleground that's giving them room to breathe and meet. So, with that in mind, that is the real reason that Tornado Alley exists. And again, it's not just a simple box drawn on a map, and tornadoes don't just simply stop or start near its edges. However, it does draw a bit of the picture and explain why it's so prime for these conditions. NOAA's National Centers for Environmental Information describe Tornado Alley as a region ideally situated for supercell formation. And when you look at the geography, it all starts to make sense as to why. Tornadoes are not exclusive to the United States. They happen all over the world. We've seen them in the UK, in Canada, in Germany, in South Africa, Australia, Bangladesh. The point is, it can happen anywhere. But that's when the right ingredients very rarely mix together. And that's where the difference is. The huge areas over the center of America provide the perfect environment for the four ingredients to come together. All of that moisture, the instability, the lift from the cold fronts pushing down, and that key ingredient wind shear from the jet stream above is present again and again and again. And there are very, very few places that are like that in the world. When people hear the phrase Tornado Alley, they usually picture the classic Great Plains states. Texas, Oklahoma, Kansas, Nebraska, and that region is famous for a reason. It has a long history of powerful supercells, huge storm structures, and violent tornadoes. But tornado risk is not locked inside one little neat box on a map, and it's not an official wall. Tornadoes do not reach the edge of Kansas, check the boundary, and then politely turn around. The reality is a lot broader than that. Tornadoes can happen across large parts of the United States, and some of the most dangerous tornado environments are found farther east and southeast, and this is where you might have heard of Dixie Alley. Dixie Alley usually refers to parts of the southeastern United States, including areas like Mississippi, Alabama, Tennessee, Arkansas, Louisiana, and Georgia. And while the storms there may not always look like the dramatic isolated supercells that you see in the Great Plains, they can be extremely dangerous. And in the plains, tornadoes form over these flatter, more open landscapes. Visibility can be better, and storm spotters may be able to see the storm structure from miles away. In the southeast, things can be very different. Terrain is more wooded and uneven. Visibility can be poor. Storms may be wrapped within heavy rain. Tornadoes can happen later at night. And in some areas, more people live in mobile homes or other vulnerable housing. And all of these together make tornadoes harder to see, harder to track, and more deadly. Not every tornado comes from a classic isolated supercell either. In fact, in the southeast, tornadoes can also form within lines of storms, sometimes called QLCS events, which is short for quasi-linear convective systems. Instead of one isolated rotating storm, you may have a long line of thunderstorms or a squall line with smaller areas of rotation embedded inside of it. And these tornadoes can spin up quickly, sometimes with less visual warning than tornadoes further east. So when we talk about America being tornado prone, we should not imagine one narrow strip of land. The risk shifts by season, region, and storm setup. And while the Great Plains are still central to the tornado story, the southeast is a major part of it too. And this is perhaps why the phrase Tornado Alley can be useful, but also misleading. It points us towards an important region for sure, but it can also make tornado risk seem more fixed and limited than it truly is. The better way to think about it would be that tornado risk follows the ingredients. When moisture, instability, lift, and wind shear overlap, tornadoes become possible. And in the United States, that overlap can happen across several regions, not just one famous place. In summary, the reason America gets so many tornadoes is due to many factors. The geography that surrounds the Great Plains, the Rocky Mountains, going north to south rather than east to west, allowing all of the moisture from the Gulf to move up, while dry air spills off it down into those plains below as well. But that air moves, and it doesn't just stick to that one tornado alley, and it can spread across most parts of America. And with that in mind, it could happen anywhere. It could happen in the United Kingdom, it could happen in Canada, it could happen in South Africa, it could happen in Germany. All it takes is the right ingredients to come together perfectly to create the perfect storm.